Alright, this is chapter 2, section 6. Proving angles congruent. Uh, we have now done a couple proofs, algebraic proofs and so forth. We are diving in headfirst into proofs now. And this section deals with, it will throw a lot of theorems at you, and there's going to be a lot of proofs associated with this section, so you have been warned. Alright, so the first thing they tell you is the definition of a theorem. Up to this point, we've done properties and postulates. Now we have something called a theorem. And a theorem, so essentially it's a rule that you have to prove. So theorem is a conjecture or statement that you prove true. So up to this point we had postulate, which was a statement that you didn't have to prove true. We had properties, we had rules, we didn't have to prove them true. Now we're in theorems where there are statements and stuff that we do prove. So the first theorem they give us, and the one I will use a lot in this course, is vertical angles theorem. I call it VAT. Vertical angles theorem. And we have vertical angles 1, 2, 3, and 4. What vertical angles says is that if I have vertical angles 1 and 3, angle 1 is congruent to angle 3, directly across from each other. And angle 2 is congruent to angle 4, directly across each other. Angle 1 is congruent to 3, angle 2 is congruent to 4. Vertical angles theorem. We will use this a lot. So there is the proof for the vertical angles theorem. It's not the best proof in the world. I've seen better. But okay. Number 1 is our given, so I'm not going to write it down because it's right there next to you. They're vertical angles. 1 and 3 are vertical angles because it's given to us. Number 2, angle 1 and angle 2 and angle 2 and angle 3 are supplementary. And if you recall, in supplementary, I'll go to SUPP. If you recall, supplementary angles are angles that add up to 180 degrees. So if we know, and we know that they're supplementary because they form a straight line. So 1 and 2 form a straight line, 2 and 3 form a straight line, so they're supplementary. And this says linear pairs. Since they are adjacent angles that form a straight line, they're linear pairs. So linear pairs are supplementary. So then if they're supplementary, then they add up to 180 degrees. If they're supplementary, then they add up to 180 degrees. The book says the sum of supplementary angles is 180. I don't like that reasoning. you're going to say definition of supplementary angles. Definition of supplementary angles says that if there's supplementary angles, then they add up to 180. Definition of supplementary angles. Alright, first step, they're given. Second step, since they're linear pairs, they're supplementary. And if they're supplementary, then add up to 180. Notice that angle 1 plus angle 2 equals 180. Angle 3 plus angle 2 also equals 180. So I can say that angle 1 plus angle 2 equals angle 3 plus angle 2. Angle 1 plus angle 2 equals angle 3 plus angle 2. We can say transitive property of equality. And remember I called it TPE. Or we can say because of substitution. Either way. But this is more so transitive. If A equals B, B equals C, then A equals C. So this is transitive property. Notice that there's a 2 over here, and there's a 2 over here. There's a 2 over here, and there's a 2 over here. So that means that I can subtract those guys out. So I can say that angle 1 equals angle 3. Why? Because I use the subtraction property of equality, which says that I can subtract the same thing from both sides. I can subtract the same thing from both sides. Alright, almost done. The last step. If they are equal, then they are congruent. If they are equal, then they are congruent. And you can say definition of congruent angles. I call it definition of congruency. So that's how I shorthand it. Definition of congruency. If they're equal, then they're congruent. You have to change it over to congruency. And this is the proof of vertical angles theorem. This is the vertical angles theorem's proof. Okay? They have a got it number 1 here. They give me 3x and 2x plus 40. They are vertical angles. They're right across from each other. So since they're vertical angles, then I can say 3x equals 2x plus 4. D. I can search 2x on both sides and get that x is equal to 40. Voila. Vertical angles are always equal. Alright, so we have another proof. We're going to do this proof in the problem number 2, but I'm not going to do the proof for 2a. It's silly. It's a silly proof. I don't like it. I call it a busy proof. It's a proof that you don't really need. So we have this scenario here. We have 1, 3, 2, and 4. And we're given that that angle 1 is congruent to angle 4. And we have to prove what? To this. Angle 2 is congruent to angle 3. Okay, so like it's a 5-step proof. So from now you can't even cheat, right? Just how this would be helpful. Oh. How is this? Alright. Here's our scenario. We're given that 1 is congruent to 4. So 1 and 4 are the same. They want to prove that 2 is congruent to 3. Here's the deal. I know, just eyeballing it before I do anything about this proof, I know that 2 and 4 are congruent. I know 3 and 1 are congruent because they're vertical angles. If 1 and 4 are congruent, and 1 and 3 are congruent, then I can say that 4 and 3 are congruent. 4 and 2 is congruent. I know 1 and 3 and 1 and 4 is congruent. I can say that 1 and 2 is congruent. So if 1 is congruent to 2, I also know that 1 is congruent to 3, then I can say that 2 is congruent to 3. I'm going to say that again. 1 and 4 are congruent. I know that 1 is congruent to 3 because of vertical angles. So 1 is also congruent to 3. 2 is congruent to 4. I know that 1 is congruent to 4. So then I can say that 1 is also congruent to 2. So 1 is congruent to 2. 1 is also congruent to 3. Then I can say that 2 is congruent to 3. Let's see how that works. Alright, 1 is congruent to 4. Given. Step number 2. 4 is congruent to 2. Why? Vertical angles theorem. Four is congruent to 2, vertical angles theorem. Okay? If 1 is congruent to 4 and 4 is congruent to 2, remember these 4's can cancel out, right? I can cancel out these 4's. And I can say, hey, 1 is also congruent. Whoops. 1 is also congruent to 2. And 1 is congruent to 2 because of the transitive property of congruency. Not equality, congruency, because all these are congruent symbols. Okay? So we have established that 1 is congruent to 2. Vertical angles also tells me that 1 is congruent to angle 3. Again, vertical angles there. Right? Actually, I'm going to rewrite this to make it look prettier. Angle 3 is congruent to angle 1. And again, I can cancel out these angle 1's. And I can say, okie dokie, if 1 is congruent to 2 and 1 is also congruent to 3, then I can say that angle 2 is congruent to angle 3. Transitive property of congruency. Transitive property of congruency. So 1 is congruent to 4. 1 is congruent to 2. And 1 is congruent to 3. Notice there's two types of transitive properties. There's transitive property of equality, TPE, and there's transitive property of congruency. They do the same process, but congruency deals with the congruent symbol, equality deals with the equal symbol. Please know the difference between the two because you will state them separately. Alright, paragraph proofs. So, paragraph proofs is a proof. But instead of doing two columns, you're basically writing a paragraph. And the way that I do these is that I actually write, actually let me go back. I actually write the two column proof because I just see things better as a two column. And then after I do the two column proof, then each line basically is a sentence. So this is a 5-step proof. This is a 5-sentence paragraph, essentially. You can convert them if you want to make them less than that. So here's how I do it. I'm not going to write anything. I'm just going to read it. Matter of fact, this is the paragraph proof to the proof that we just did up here. So this is the same thing. So I'm going to read this because this is essentially the same thing. So angle 1 is congruent to angle 4 because it's given to us. Due to the fact that vertical angles are congruent, or due to the vertical angles theorem, angle 4 is congruent to angle 2. And since because of the transitive property of congruency, I can say that angle 1 is congruent to angle 2. Also, because of the vertical angles theorem, angle 3 is congruent to angle 1. Lastly, because of transitive property of congruency, angle 2 is congruent to angle 3. Just eyeballing it. Really, really straightforward. I would draw the two column proof, and then each statement is a sentence, and then turn it to a paragraph. Congruent supplements theorem. And what the congruent supplements theorem says, and again, I'm not going to write these down because it's quite a bit of writing. So I'm going to just put it up here on this side. The way that I write congruent supplements theorem is like this. I write the congruent symbol, then I say sup, just like this, congruent supplements, and sometimes I write theorem, sometimes I don't. Congruent supplements theorem. And what the congruent supplements theorem says is that if I have two angles that are the supplements of the same angle, or they're congruent to the same angle, then the two angles are congruent. Alright, what does that mean? Here we have three angles, angle 3, angle 1, and angle 2. It tells me that angle 1 and angle 3 are supplements. These guys are supplements. Angle 1 and angle 3 are supplements, meaning that angle 1 plus angle 3 equals 180 degrees. Okay? I'm also told that angle 2 and angle 3 are also supplements, meaning angle 2 plus angle 3 equals 180. Okay, so let's substitute these with numbers. And let's say that angle 1 equals, actually say this. Yeah. Let's say that angle 3 equals 100. Okay? Angle 3 equals 100. So when I rewrite these, I'll have angle 1 plus 100 equals 180. Here I'll have angle 2 plus 100 equal 180. Okay? If I subtract 100 on both sides, then angle 1 must equal 80. If I subtract 100 from for both sides, angle 2 must also equal 80. So since they're supplements to the same angle, angle 3, then that means that angle 1 has to be congruent to angle 2, because when we set them up to add up to 180 and subtract the same angle from both sides, these guys have to be the same. So this is the congruent supplements theorem. If two angles are supplementary to the same angle, if two angles are supplementary to the same angle, then they are congruent. Congruent supplements theorem. Alright, so they want you to write a paragraph proof. Again, like I said, usually when I do these, I write them as two-column proofs first. So I'm going to do it that way. They already give you the proof, but I'm going to write this as a two-column because it's good to know this as a two-column because you might see it on the test. So 1 and 3 given. Actually, I'll just write it out here. This is the proof for congruent supplements theorem. Alright. Here's what they give us. They give me that 1 and 3 and 2 and 3 are supplementary. They give us this. Number 2, if they're supplementary, then 1 plus 3 equals 180, and 2 plus 3 equals 180. Oh man. Hate when that happens. Don't you just hate when your screen doesn't cooperate with you? Definition of supplementary angles, which says that if they're supplementary angles, then they add up to 180. Notice that they both add up to 180. So since they both add up to 180, they can add to each. They equal each other. They both equal the same thing, rather, than they equal each other. So angle 1 plus angle 3 is equal to angle 2 plus angle 3. And that's because of the transitive property of congruency. I'm sorry, of equality. I will also accept substitution. Again, notice that they both share angle 3. They both share angle 3. So then I can say that angle 1 is equal to angle 2. Subtraction property of equality. And if they're equal, then they're congruent. Definition of congruent angles, or definition of congruency. Alright, so they give me that they're supplementary. If they're supplementary, then they add up to 180 degrees. Definitions of supplementary angles. If they both add up to 180 degrees, then they equal to each other. Transitive property of equality, or you could use substitution. Since they both have angle 3, I can subtract that out, and I can say that angle 1 is equal to angle 2, and since they're equal, then they're congruent. Definition of congruency, and then the paragraph proof is right there as stated. 1 and 3 are supplementary because it is given. So the measure of angle 1 plus the measure of angle 3 is equal to 180 by definition of supplementary angles. 2 and 3 are supplementary because it's given. Therefore, angle 2 and 3, the measures of angle 2 and 3 equal 180 due to the same definition. By the transitive property of equality, angle 1 plus angle 3 equals angle 2 plus angle 3. You can subtract from each side using subtraction property of equality. Subtract measure of angle 3 Therefore, the measure of angle 1 is equal to the measure of angle 2. And if angles are equal, then they are congruent. They want you to write a paragraph proof for vertical angles theorem. So vertical angles theorem, the proof for it we already looked at, which is this guy here. So you just turn each line into a sentence. I'm not going to write it, but you can. So I can just read it to you. Each statement is essentially a sentence. Angle 1 and angle 3 are vertical angles because it's given. Angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary because linear pairs are supplementary. Therefore, by the definition of supplementary angles, the measure of angle 1 plus the measure of angle 2 equals 180. Likewise, the measure of angle 2 plus the measure of angle 3 also equals 180. Due to the transitive property of equality, measure 1 is plus measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. You can subtract the measure of angle 2 from both sides and say, due to the subtraction property of equality, that the measure of angle 1 is equal to the measure of angle 3. And if they are equal, then they are congruent due to the definition of congruent angles. Thus, angle 1 is congruent to angle 3. Highly recommend you write a 2-column proof first, and then basically turn each line into a paragraph. Alright, so they give us some more definitions, or theorems rather. So we just talked about the congruent supplements theorem. We also have the congruent complements theorem, which says that. So congruent complements theorem, which says that, and the way I write this is the congruent symbol, complement, and then sometimes I write theorem and sometimes I don't. And it says that if two angles are complements to the same angle, then they are complements. So if angle 1 plus angle 2 equals 90, angle 2 plus angle 3 equals 90, so the same thing as before with the congruent supplements. Let's say that angle 2 equals 30. Then I can say that angle 1 plus 30 equals 90. Angle 2 plus 30 equals 90. So if I was to subtract 30 from both sides, angle 1 would equal 60. Subtract 30 from both sides, angle 2 would equal 60. Right? So since they both equal 60, then I can say that angle 1 is equal to angle 2. Therefore, I can say that angle 1 is congruent to angle 2. If two angles are complementary to the same angle, then they are congruent. Theorem 2.4 says that all right angles are congruent. All right angles are congruent. So, we have two right angles here. If angle 1 and angle 2 are right angles, then they are congruent. All right angles are congruent. So, if you wanted, all theorems, most theorems for the most part, are put in if-then form. So here's the if and the then. This is how these definition works. So, if, this is theorem 2.4, angle 1 and angle 2 are right angles, then these are all going to be the form of conditionals. Angle 1 is congruent to angle 2. Okay? So when you write these definitions down, it would be good if you are there. Since we're doing these in this particular way. Theorem 2.5. If two angles are congruent and supplementary, then each angle is a right angle. This is stupid. Don't care for this. I put this there. So angle 1 is congruent to angle 2, and angle 1 and 2 are supplementary. Then angle 1 and angle 2 equals 90 degrees. So here's the essence of 2, 5. Again, when you write these in if then statement. I'm not going to write the definition because it's here. But if angle 1 is congruent to angle 2 and angle 1 and angle 2 are supplements, then angle 1, the measure angle 1 is equal to the measure angle 2, which is 9 degrees. Here's what they're saying. I know, let's call angle 1 is congruent to angle 2, right? So let's also say that, okay, if they're congruent, then they're equal. Okay? Let's also say that angle 1 is equal to x. If angle 1 is equal to x, then angle 2 is equal to x. Okay? Alright, having said that, we can say that angle 1 plus angle 2 is equal to 180 because there's supplements that's given to me as well. They're supplements. I'm going to substitute 1 and 2 with x because I said they're equal to x. So I'm going to say x plus x equals 180. Add these two guys together, I get 2x is equal to 180. Divide by 2 and I get x is equal to 90. So if x is equal to 90 and I know that x is equal to 2 and x is equal to 1, then I can say that 1 is equal to 2, which is equal to 90. That's where that thought process is coming from. If they're the same angle, if they're equal, and if they both add up to 180 degrees, then they must be 90. Alright, so that's that section. Hope you have a great rest.